this big bright spot at the back here, while the rest of it is sort of, darker up here. And that just happens to be a function of the 8-channel coil that we're using to acquire our scans, and that produced this sort of artifact that we're seeing here. So using N3, we can sort of normalize this inhomogeneity from our scans. And then, again, you get an additional benefit from using the intermediate template once you've now done that, to improve the overall warp.
If you go into your directory there, it looks like you have the N3 native file there. You have to look at the code like that. So, well, you don't have the original one.
No, I don't.
Or the original form of level up.
I don't know. It's not.
Okay,
I'm pretty sure it's not. Yeah. All right. And obviously you can get the N3 tool from there. I'm not sure. Is N3 built into ANTs?
no,
Or does it come with ANTs?
From here. It's from Montreal.
Yeah, I didn't know if sort of Brian includes it within his ANTs.
Other ways to correct inhomogeneity, STM will do it. But I know,
Yeah.
I know the secret to making N3 work. So.
Yeah, okay. So that's why we tend to use N3. FSL also, I think, has a... Okay. I know there's also, Susan in FSL, which will also do that. Oh, you're right. Sorry. That's the denoiser. I don't remember what is the... Do you remember? Well, anyway, many different packages have this inhomogeneity correction tool. I don't think that's fast. I don't remember what it's called. But anyway. So next is, once you run the ANT script, what are the outputs that you're going to sort of get? Usually you'll get this, as you can see from this directory here, you get a series of files, and essentially the files are, you're getting the affine file, subject file. This file actually has the parameters outputted. The next are the different deformation parameters for the warp and the inverse warp. And then it's going to output basically all of those images in the different warp formats. Yeah. Yeah.
Not often, but...
Okay, so never mind then. I thought that. So affine transformation, all the transformations take place via this.
Yes.
This is all that manipulation.
Exactly. And
You're talking about diagnostics, right?
sorry?
About diagnostics. About figuring out what went wrong.
Yeah, I'm going to try a little bit about it. It's actually, I think it's one of the hardest parts of this whole process is how to decide, when a warp goes wrong and why. Other outputs that it just spits out is the N3 normalization, sort of the parameters that were used within the script. So let's say you change the defaults, the params file would list what parameters were used for that specific warp, and then elapsed basically is just how long it took to run. So evaluating the different warps, right? As I said, I think this is one of the, just before I do that, I'll also show you a quick view of what the actual script for ants looks like. Basically, that's it. I won't go into any detail. We've sort of already gone into the in-depth details of exactly what it's doing. So, but I guess most people are interested in the actual warps themselves and how do you evaluate them, right? So what I have here is one subject's warp, what I would consider to be sort of the larger lesion. Not the largest that we've tried to warp, but a reasonable, good-sized lesion. You have the colon template, the colon brain. So basically, this is the subject, and we want to get to colon space. Using ants, this is an example of how one of the how one of our warps goes. This one is not the best possible warp because you can sort of see. Number one, let me start off by saying that this issues with the skull outside we're not really too concerned about because it's the skull. We really don't care too much how that's gone. But we are sort of interested in this rippling effect here. This is sort of not as consistent as we'd like. If you bounce back between sort of colon and the subject wart, you can see, number one, it does really good with the ventricles, right? So that's clear. Most of the gyri and sulci, sort of if you look in this area, sort of match up very, very well. And you know what? I'm going to go ahead and also add, so you can get a sense of, in the 3D planes, what it's looking like. But again, bouncing between the two, you can kind of see just how well it's squeezed, essentially. This subject's brain, right, which also has a pretty good pitch angle into the colon brain fairly well. Cerebellum is doing pretty good. As far as checks, what I'm looking for to evaluate if I think a good warp has gone well, number one is the ventricles. Has it done well with those? That's the biggest thing because, as we've talked about, our subjects have, these huge ventricles. This guy has a pretty good. Distortion going on there in terms of the ventricles. So that's one of the first things that I'm looking at is how well are those mapped. The next thing is the cerebellum, right? How well has that sort of pitched? In this case, there's not that much difference, but, this little strip down here.
What happens if I'm trying
Colony.
to figure out each step what it would look like if it doesn't work well. So if what does it look like if the ventricles don't look good?
It will look closer to the actual patient's ventricles.
Oh, really? So it will be large like that?
Exactly,
So
it will be
see the
large.
Distortion of the
Exactly.
in that way. Okay.
Actually, that's easier thing to fix, but I think more problematic when you use this kind of large deformation scheme is that it looks like patient, it looks like template, but there's a distortion in cortex or
Yeah. So in this one, you can clearly see that it's not exactly perfect. So there's still a little bit of, not sure.
So what
There's a little bit of distortion here in cortex.
So what we get, the type of distortion we get more frequently is that it tries to match the patient's brain with the template too hard. I mean, that's what
That's the goal of your.
So it's overfitting it. So lesion is significantly. So everything else looks, pretty matched, but lesion size gets like spot, or that type of distortion is more worrisome because.
I have to say that overall, from the distortion that you're talking about, we haven't seen, I don't think, that level of distortion as much. And I'm going to say that that's possibly due to the fact that we do go through the intermediate template. We don't have.
Did you use lesion mask here?
Yes.
Okay.
So if we go back and actually click on,
The example you have here actually does show some of these sort of strange little focal mystery patterns, which I think are entirely due to the fact that our current intermediate template is not that good.
sure.
Yeah. Where are the focal mystery patterns? If you zoom in on some of them, I think some of the foci are too deep. They look a little wavy in a way that's not really related to the
Template, yeah.
subject. So really,
Definitely. Yeah, so definitely at these top right, let's turn off the crosshairs. So this sort of weird, isn't that nice? Okay.
So actually, by looking at the transformations piecemeal, by looking at the actual subject brain transforms to the intermediate template and the mapping of the intermediate template on the column brain, you can actually see that this distortion is entirely due to a bad common warping from the intermediate template to column.
Yeah.
Great news, right? Because we don't have to solve that problem
Once, yeah.
So I just want to ask you, the amount of distortion of the ventricle that you see here is not problematic. I mean, there's some enlargement of the ventricle. Is that what it typically looks like, or is that?
You're talking about this.
Yeah.
This.
I mean, is that? I'm just wondering what a troublesome level is. So, of badness.
This I wouldn't necessarily consider too bad, just because I think it's trying to, with that lesion, with that mask, right? It's essentially when you apply the mask, it's ignoring this level of cortex, and so it's saying that, presumably, if this person's brain is intact, this piece of cortex would be here. And so it actually now has to figure out where is it going to associate this, even though, sorry, if I take this off, right, where to put this distortion into. So it's assuming that it doesn't exist, if you will. So at some level, I'm not too worried when I'm looking at this particular. I mean, obviously, I think we've talked about at the higher points on this brain, especially up in here, we could definitely do some improvements. But we think that this is going to be due to essentially the intermediate template and can be
And then
improved.
let me ask you another question. At some point, Laurel and I compared our the normalized maps that we had for the same patients that had been drawn in Wimbledon and Wimbledon Plus, right? And we thought that in all or most cases, the Wimbledon Plus produced larger estimates of the lesion. And so I'm wondering, is that we assumed that was a consequence of the automated war. Do you think that's true?
Yes, because essentially, with definitely that first level, definitely with the first attempts at using this system, there was a component within the script that basically increased the lesion size by, I think, 1 or 2 voxels. Isn't that right? Do you remember this, Dan? Yes.
Oh, so that was a problem.
Yeah, I'm pretty sure that it actually.
So systematically overestimated the size. Is that what you just did?
Yeah.
Really?
If I recall correctly, we weren't entirely. I don't know if these are the same ones that I was looking at, but
No.
we weren't also completely confident that the same drawing strategy was people.
Yeah. I mean, essentially, that was why it was done.
Do you feel like you were as equally liberal as your drawing in both?
I mean, I think it should be noted that I think that we did this also because of branches